All right, this video is to show you what's called polynomial long division. But before we start dividing polynomials, let's just review long division with real numbers. So let's go ahead and divide 345 by 7. So at some point you probably learned to take 345 and draw a symbol over it, and we're going to divide it by 7. So 345 is called our dividend, 7 is called our divisor. And so what we're going to do is look to see if 7 divides, how far do I have to go to find what 7 will divide into? It doesn't have to divide into it evenly. That's okay. But for instance, can I divide 7 into 3? No. So now I'm going to take 2 digits of my dividend and say, can I divide 7? Will 7 go into 34? Yes. And so the question is, how many times? So here, 7 will go into 34 4 times. And so I take 4 times 7, and I get 28. And I'm going to subtract these two. So 34 minus 28 leaves us with 6. And then we're going to bring the 5 straight down, because essentially we didn't subtract anything from the 5. Or if you want to think about it, 0. So then we have to ask ourselves, how many times will 7 divide into 65? Well, the answer to that is 9. And 7 times 9 is 63. So 65 minus 63 will leave us with 2. And we call 2 the remainder. So 345 divided by 7 is equal to 49 with a remainder of 2. And so we could write that answer as, so we could say that 345 divided by 7 is equal to 49 plus a remainder of 2. We could list it as 2 divided by 7. So it's 49 and 2/7. Now, dividing polynomials is the same process, really. So we're going to have some polynomial of degree 2, degree 3, degree 4, and we're going to look at dividing it by a binomial. And so I'm going to set it up in a similar manner. I'm going to come over here and I'm going to allow my cubic polynomial to be the dividend, because I'm dividing it by x plus 1. So I'm going to write out x cubed plus 3x squared plus 4x plus 4. And we're going to divide this by x plus 1. Now, where it differs a little bit is that I am going to try and subtract. I want to make this x, I want to multiply it by something so that it will eliminate the x cubed. I want to make those look exactly the same. So I have to ask myself, what would I multiply x by to make it x cubed? And the answer to that is I would need to multiply by x squared. Now, once I decide on what I'm going to multiply by, I need to make sure that I line it up above its corresponding term in the dividend. So for instance, if I'm going to multiply it by x squared, this needs to take its place over the 3x squared. So then I'm going to take x squared times x, that's going to give us x cubed. And then I have to come back and take this x squared times 1. So plus x squared. And then, just as I did with the long division of real numbers, I need to subtract this. So I'm going to end up subtracting this whole thing. So we're going to look at this. And so some people like to take and distribute it and then add. It is entirely up to you. But really what I'm doing is I'm saying x cubed minus x cubed. So those are going to cancel out. Those will be eliminated. All right. And then I have 3x squared minus x squared. So this is going to be 2x squared, because remember, I am subtracting here. Then just like above, I'm going to bring down that next term, plus 4x. Or you can think about it as I subtracted 0 from it. Now what we need to do is look at x and say, what do I need to multiply it by to make it 2x squared? Well, the answer to that is 2x. And because it's 2x, I want to make sure I'm lining it up above the 4x, its corresponding term in the dividend. So 2x times x will give us the desired 2x squared. 2x times 1 will give us plus 2x. However, I am going to go ahead and subtract these things. Okay, I need to subtract them. So 2x squared minus 2x squared, those are eliminated. But now I have 4x minus 2x. Well, that's going to leave me with 2x. Let me change colors. There we go. So that's going to leave me with 2x. The plus 4 is going to come straight down. And now I'm going to look at the x that I have out here in my divisor, and I want to make it look like 2x. So I'm going to go ahead and I'm going to multiply this thing just by 2. And notice that the 2 I'm using lines up above the constant of 4 in the dividend. So I take 2 times x, that'll give us 2x, and 2 times 1, that'll give us 2. And again, we're going to subtract these things. We're going to subtract. And just like in the division with real numbers, this is going to give us a remainder. So 2x minus 2x, those are going to be eliminated because remember I'm subtracting. 4 minus 2 is 2. So I have a remainder of 2. So what I could say is that this division that was given to us, this is equal to x squared plus 2x plus 2 plus the remainder of 2 over my divisor, x plus 1. And that's how we would normally write our answer to a long division problem for polynomials. Now, let's take a look at another example, because there is a pitfall that we have to watch out for. And that's when our dividend is missing powers. So if we look at this next example, we can see that we have a cubic power or a cubed power, but we don't have a quadratic term. So we have a cubic term, but no quadratic term. And then we have a linear term and a constant. So when that happens, what you need to do is we're going to put a 0 and then the missing term. So the coefficient's going to be 0. So, and that'll just be a placeholder for it, so I don't end up messing up and leaving out a part of the quotient. So I'm going to write x cubed. And then since I'm missing my quadratic term, I'm going to write 0 x squared minus 6x plus 11. So I'm just rewriting my dividend to have that missing term in it. And now I'm going to go ahead and work it just like I would any other problem. Let me move this one down. I ran out of room, so there we go. And so my divisor is x plus 3. So just like above, I want to try and make this x look like x cubed. And to do that, I'm going to have to multiply it by x squared. So again, I'm lining up my x squared above the x squared term in the dividend. Now, if I had forgot to put the 0x squared in there, what I would have run into is I don't have a corresponding term in the dividend to line it up with. So I'm going to take x squared times x. That'll give us x cubed. And then x squared times 3, that'll be plus 3x squared. But then remember, in long division, we need to come back and subtract these two. So I'm going to have x cubed minus x cubed. Those are eliminated. Then I have 0x squared minus 3x squared. So this is going to leave us with a negative 3x squared. Then I'm going to bring that minus 6x straight down. Minus 6x. Now I have to look at it and say, all right, well, what do I have to multiply my x here at the front of my divisor by to make it look like negative 3x squared? And so the answer to that is I need to multiply it by negative 3x. And so I'm going to take negative 3x times x. That's going to give us the negative 3x squared that we're looking for. And then I'm going to take negative 3x times positive 3. That's going to give us a minus 9x. However, we know we need to subtract that. So we're going to subtract these two. Now, this is where the subtraction can get a bit tricky because we're going to be subtracting a negative. But all you have to do is remember that subtracting a negative is really just addition. So negative 3x squared minus a negative 3x squared is really just negative 3x squared plus 3x squared. So again, those will get eliminated. And then I have negative 6x minus a negative 9x, or I could think of it as negative 6x plus 9x, because that's what it really is. And that will leave us with a positive 3x. Then we're going to bring that 11 straight down. And so now I have to look at my long division and say, okay, what do I need to multiply the leading term of my divisor by, that's the x, to make it look like 3x? And the answer here is I need to multiply it by 3. So I'm going to add a plus 3 to this, to my quotient, and notice it lines up with the constant of my dividend. So 3 times x gives us 3x, and 3 times 3 gives us plus 9. And again, just like before, we're going to subtract the two. So we're going to come in here, we're going to subtract these two. And so 3x minus 3x, those are eliminated. 11 minus 9 leaves us with 2. And so we have a remainder of 2. So again, I could write my answer to the problem as presented. And the way I would format my answer is I'm going to start by listing the quotient. And that's the expression on top. So it's going to be x squared minus 3x plus 3 plus my remainder of 2 over or divided by the divisor. And that's long division of polynomials.